Hello everyone, my name is Wei Chen Su. I'm currently a student at Suzhou University, majoring in financial engineering and actuarial mathematics. The topic of this project is analyze and clean MLB data and apply machine learning tools to hazard classification table. This is my content. First is project introduction. Second is research method. Third is calculation. Project introduction. At present, most of the sport-related insurance provided by Taiwanese insurance companies are available to ordinary people when they are injured, and provide small compensations. Therefore, this research will try to propose a set of effective methods for the pricing and the calculation of sport insurance for players injured through the method of machine learning, which can provide a reference for insurance companies with a new pricing method. Research method. I take baseball player data as the research targets. Injury and the series of player data is incomplete in Taiwan Chinese professional baseball. So I use the American Major League Players data for this research, comparing other nations' insurance. In American, baseball player is in senior high school has the catastrophic injury insurance programs provided by the NCAA to transfer the injury risk of student athletes and provide medical injury and deal benefits. In MLB, the players themselves can buy loss of value insurance cover the risk of loss caused by contract conversion due to injury, or you can purchase draft position loss insurance to cover the loss of poor draft picks. The team can purchase temporary disability insurance to protect the team's loss of players' salary due to players' injury and failure to play. And the team can purchase important person insurance to protect the team from the loss of the team's failure to successfully enter the playoff series due to the injury of the main players. In Taiwan, most of them only provide casual injury insurance, which obviously cannot meet the need of professional players. So I wanted to discuss the pricing aspects of professional player injury insurance to improve sport environment. I divided the research method into two parts. First, observe injury data. Second, model building and judge. First step, injury facts analysis. I use the data of Major League Baseball players to analyze the defensive positions, injury types, and the injury site. The injury rate was the number of injuries divided by the total number of people. And I can find that in the Major League Baseball, the injury rate of pitchers is higher than that of hitters. From the phenomenon of injury distribution, three discussions can be inferred. First, the most likely injury site for MLB players as the world is able, which accounts for 28% of the overall injuries. The backs, which counter for 20% of the overall injuries, and the shoulders, which counter for 18% of the overall injuries. Second, strain is the most common types of injury for American baseball players. Third, players in different defensive positions will cause different types of injury. Second step, re-injury rate. I use the player's injury data to make a table of re-injury rate. The algorithms of the re-injury rate table is to divide the calculated number of injuries for the next time by the calculated number of injuries this time. And then the number of injuries can be calculated. For example, the number of injury for the first time is the number of calculated injury for the second time, dividing the number of the calculated injury for the first time, and so on to calculate all the value in the tables. We can observe from the figure 2 that the probability of re-injury rate is getting closer and closer to 15%. In other words, the re-injury rate is become more and more redundant. In addition, it is more from the accurate value of the data that more than 12 injuries still remain in the major range. There are very few people, so it can be inferior than when both players stay on the court, and the player who is injured more often is not necessarily more likely to be injured again. This result seems to be consistent with common sense, but from the overall trends, I feel the result will be a major issue for athlete injury insurance. After a series of discussion on injury factors, injury rate, the re-injury rate, I focus on the insurance pricing. The proposal is know whether the athlete is likely to be injured or the risk of insurance claims after insurance is high. This is not too big, and we can calculate the different insurance benefits for each athlete according to different risks. So I will use the previously collection data and the player related variable into machine learning to try to find the best model and provide virtual predictions or under screening criteria. Third step, model selection variables. I put a collection 24 different relative variables of the players into the classification trees algorithms and test each possible combination. It can be found the least data and the best accuracy are about 1.1%, and when the highest accuracy can be achieved when the variance is 3. So this model is selected as the best model, and its variables are selected as the best variables. A merge lens in order to try to improve the accuracy and refer the previous results. The injury rate between pitchers and batters are different, and the natures of each other is also different, so the dataset is divided into two types, only pitcher and only batters, and using classifications trees Chinese. You can find the best accurate rate of pitchers reaching 84.4%, which is significantly improved, but the result of the only batters classification trees are still the same as the ordinary accuracy. Therefore, it can be inferred that pitchers' data may be more similar or a collection variable may be more able to explain the pitcher's data. Fourth step, risk model injury rate. I use the classification result of classification trees of all player data to classify the players into 12 categories, but 4 of the players into the categories has no injury records. So I combine these 4 categories into the same category to get 9 players with different risk level injury risk table. This table can use the analysis of the 3 variables of past injuries, record the number of games played, and the coach stealing to classify different players into different injury risks. I can use the calculated injury times the number of injury days and salary calculate the cost of the teams or the player and provide suitable insurance assistance to solve the problem of no insurance payment after the player's injury. Next step, model evaluation. I use machine learning to evaluate the model using the 4 major indicators that are often used to measure the quality of a model. First, the accuracy score of the 71.1%. means that there is the 71.1% chance that the model result of the test state will be correct with the true value. Second period scores 65% means that 65% of those predicted to be injury are accurate injuries. Third, recall scores 93% means that 93% of the people who are accurate injuries are accurately injuries. Third, F1 score is used to judge the quality of the overall model. The closest is 100% means that it has good predictive ability, and the model is 77%, which means it has predictive ability. Conclusions. This project found that the defensive position is related to the injury types of injury site, and the injury rate of pitchers is higher than that of batters. Strain is the most common injury site for American baseball players. The most easy injury sites are elbow and the back, and the shoulder. From the perspective of players, there can be corresponding guarantees to reduce their injury loss and subsidize medical expense. From the perspective of insurance companies, they should carefully evaluate the corresponding risk when deciding in the cut of the injury rate. It can be shown that when a player can continue to play with multiple injuries, the possibilities of re-injuries is not necessarily higher than that of a player with a few injuries. The model finally built and has a good F1 score, and the recall is higher. That is when the model predicts the players will be injured. It means that the players has a high probability of being injured. Therefore, it is possibility to continuously track the data of the Chinese major league players' injury history and salary, or use the machine learning result of the injury data of American players to make up for the lack of data on Taiwan players, and improve the sport risk system for Taiwan players. My report ended here. Thank you for your time. If you have any questions, welcome to discussions with me.